Welcome all of you on platform of YourPedia Education, and you are watching the interaction series with the professors and researchers in different universities of the world, in which I interact with them and we try to understand what research area they are working and where is the scope of further research in these particular areas. So today's interaction is with one of the professor in Nottingham Trent University, which is called NTU, which is in UK, Nottingham, somewhere around Manchester. I think this is the location, Birmingham, near London. So you can see this is the location of this university. And Professor Neil, we are going to interact with Professor Neil today. He's the head of the Department, School of Science and Technology, NTU. Let me tell you something about his background. He has served in different universities, including Imperial College London and presently NTU. And he's mainly in the domain of School of Design Engineering and Human Factor Engineering and Ergonomics. So a lot of research has been done in the field of Human Factor Engineering and in the ergonomics and vibration and design aspect, sound and vibration research. He started his career from automotive industry. Later on biomechanics he has worked, biomechanics of drivers when they are exposed to vibration and shock. So that is the domain in which he has worked. He has research areas which are designing for dynamic environment like vibration and shock, design for vulnerable users like very small children sitting in the vehicle. So mining, agriculture, military vehicles, sports equipment, all domains of research which he has, we try to discuss with him. So I asked certain questionnaire, I sent him, I asked certain question to Professor Neil, like a journey from his university, from Imperial College, then NTU, brief about design engineering, which he is working in, human factor engineering, what are the latest projects in which he is working, and what is the vulnerable users, industry 4.0, and if some Indian students want to go and pursue higher education or research further, how it is to be done. See, the most important answers for you, those of you who are targeting to go these universities for higher education further, they are towards the end. So if you skip the video, please don't forget to watch at the end a couple of minutes, because there I have asked Professor Neil that what do you look forward in a candidate who wants to do PhD under your guidance. He said that fellow should be interested, he should be innovative and interested in his own domain of research. That is what I look forward to, because it is his PhD, not my PhD. So if you're interested in your work and if you're innovative or creative in that domain, that is what I look forward to. That is what is the answer given by Professor Neil. I'm very sure you will get benefited from this video, and this is my genuine request that if you like it, we are thankful to Professor Neil for sharing his ideas with all of us. So if you like it, please don't forget to give your comment. That will be quite motivating for me and a kind of token of thanks to Professor Neil. Thank you. Okay, Professor Neil, welcome on YourPedia Education, and it's thanks to you from entire community from India, researchers, students, everybody. Professor Neil, I have certain questions to ask you today, though I have already given your introduction before this video. So I have certain questions. I think we start now directly. Sir, you have served as faculty in different universities. What I know is Loughborough University, Imperial College London, and then NTU presently, Nottingham Trent University. So I just briefly about your this journey from one university to another.
Well, my journey started before that. I actually was at University of Southampton originally, and I spent some time working in the automotive industry. So I came from industry into university, and I started working in vehicle design, particularly vehicle seating, but not just cars, right across from industrial machines and forestry. And that actually took me to Sweden. I worked in Sweden for 2 years, working with the forestry industry, and then from there I went to Loughborough, where I was for 16 years, and working with human factors engineering. So that's where I became a professor of human factors engineering. So where we're wanting to work with engineering, but to make people perform at their best, and also to make sure so that it would include people being able, for example, to fly a military aircraft. You need people to perform at their best. So you need to design it so they can perform at their best. Or it might be someone who is 90 years old driving to the shops, and if you do not design can then get in and out of it, it's actually the same problem. You've designed people out of it. They cannot perform what you need them to do. So that's what I was doing when I was at Loughborough. From there, I set up a Department of Design Engineering with some colleagues at Imperial College London, and I moved on from there. Once that was established, to Nottingham-Trent to again set up another department. So this is a new Department of Engineering at Nottingham-Trent in the middle of England, and so we've set that up. And we've been going, what, 4 years, almost 4 years now.
Okay, so Professor Neil, I can see that largely your work is in human factor engineering, design engineering. That is what you have done in Imperial College London also. So we would like to know about this research field more, sir. What is all this all about? Vibrations and designs you have worked.
Yeah, I'll give you some examples for, just from some of the things I'm working on now. So I'll give you 3 different projects that I'm working on. So one of them is looking at very vulnerable people, and this is premature babies. So babies that are maybe 6 or 8 weeks early when they're born. And there's a real problem because they need a lot of care, and they may need to go to a specialist facility, but how do you transport them from one place to another? And that's a real problem because that's a very dangerous thing to do. So we're working on designing the ambulances and to what we call neonatal transport, to protect the person, to protect the child, to protect the baby during that transport process, so then they can get better care in the new location. So that's one type of thing we're doing, and there we need to understand the biomechanics. So that's how the person responds, how the baby is responding, and then we use that to design like the incubator, which is then isolated from the shock and vibration. So that's one extreme. I'll go to another extreme where we're working in a marine environment, that with special forces and with the lifeboats, an organisation called RNLI, which is a lifeboat institution in the UK. And there is a similar type of problem. So, except this time it's adults, and they must go to rescue people, or they must go onto their military mission in the highest of seas. And what happens with those boats is they come off of a big wave, and then they come into the next trough, and they're actually in free fall. So you've got a boat weighing many, many tons, and it's going into free fall, and then it will hit the water.
Yes.
Most of the time this is okay, but sometimes you imagine a really rough sea and the boat is moving around, and so there we need to design so we can isolate the people in the boats, and we design it so they can drive the boat. That's another important part. It's not just isolating them, it's so that they can control it at the same time. And then the third one is a project I'm working on with aircraft, where we're looking at making the aircraft interiors much more comfortable, but not for jet aircraft, it's for the turboprops. So aircraft that have propellers, they are incredibly efficient. They don't have a very good reputation, but they're so efficient as a means of transport over long distance. And we need to make them a better environment. And so we're at an early stage of being able to do that. So we need to understand the noise and the vibration and what we can do about it. Fundamentally, you've got a propeller, and behind that propeller there's a wake, and that keeps on pushing against the wing, of course. So there's a lot of vibration and noise. It's just part of the system. So in the long term, we'd like to develop a new generation of aircraft. But at the moment, we're building simulators. So it's a big project with many partners across Europe. So those are kind of those 3 areas. So those are things I'm working on. So you can see they really blend the technical side of the engineering and understanding the dynamics, right the way through to the biomechanics and understanding how people really respond in those environments.
Professor Neil, you have mentioned about the projects in different areas, and you mentioned about the vulnerable people also. I was going through your profile, and you mentioned even in sports. Sports is a very big domain for that. I was going to ask you, sir, as you know, India is an agrarian country, so their agriculture devices, you must be knowing, there's tractors, people are using that. So are you focusing on those domains also? Because there also this problem is very severe.
Yes, I totally agree. And I actually had a project a few years ago now where we worked with Indian Railways and IIT Delhi and IIT Roorkee to actually work in that environment. And part of that was focusing on the application of tractors. Where many of my visits there, the challenges are very different. in different parts of the world. There are some companies who have tried to develop very high-tech tractors going into more rural locations, and they're wonderful tractors, but when something goes wrong, you can't get the spares. You can't fix them without a specialist, and that just doesn't make sense. You have something very valuable that's worthless. So it's a very different challenge, and even down to really simple things. So, like, how do people operate pedals? In a mine in Europe, people will be wearing boots. They'll be wearing a special type of boots. If you then go and take an environment where maybe people have a very different type of footwear, and you have a very sharp pedal, then of course that's something which is going to be really painful for someone to operate. And so those are real examples of where the design has not really been thought about into the environment. So what part of the thing that I've been trying to do is to develop much more of a global view on how we can do inclusive design. So inclusive design doesn't just mean designing for maybe people with a disability or a different age, but it's designing for different cultures, different ways of working, different clothing, and all of these need to be taken into account if you are going to design something which is acceptable across the world. From number of people sitting on a motorcycle, there's a classic thing that we see in India especially, and that just, you would not see that if in other countries around, or certainly if things are designed in Europe or North America. So you need to understand how things are going to be used in context and embrace that and design for it.
When you say vulnerable sections, sir, which group it comes? Small babies and old people, defense people also. What comes in the vulnerable section? That is the term which you used.
So can you ask the question again?
You use the term vulnerable people, vulnerable section. So my question was, is that only for small babies and very old people, or some another group also comes within this vulnerable section?
Okay, yeah, I understand. Yeah, so I think the vulnerable people, everyone is a vulnerable person.
Yeah.
If you have ever broken your arm, you understand some of the challenges that you might have. So someone may have maybe a parent, and they're pushing a buggy or pushing a pushchair, a pram with a baby inside. Well, they're facing the same challenges as maybe somebody who's a wheelchair user. So the vulnerable people could be right across the whole of community. Maybe you're a carer of someone who is an older person with special mobility problems. So you will then become part of a package of being a vulnerable person as a package. So I think it goes right across. But I actually would say anyone who's at the extreme of their limitations is a vulnerable person. And that could be someone who is a racing driver. They're right at the extreme of performance. It could be someone who is an aircraft pilot. They're at the extreme. It could be an athlete. They are at the extreme of their performance, and I find things really interesting. Or it could just be someone working in what we think is a more routine job, and suddenly the workload goes up. They're at the extreme of their performance. They have 20 things to do, and they have a limited amount of time to do them. Otherwise, maybe they're a train driver, and suddenly something unexpected happens. They're right at the limit of their performance. We need to understand that, the limitations of what they can do, and design the system so they can get, it's quite straightforward. You need to get the information to the person so they understand it. Right. They then have to take a decision, and they have to implement that decision. And all of those need to be possible. So if you're any part of that, those three parts of that system, if they fail, if you cannot communicate to the person, or they don't understand, or they can't actually implement their decision, then that system will fail. So I would say anyone who's at the limit of their performance, I say it is vulnerable. Things could go badly wrong at any moment.
Right. Professor Neil, when we talk about human factor engineering, I was seeing that your more focus is on vibration part, or maybe sudden change in motion. What about those situations where a person is not in the vibration or dynamic situation, but for long hours of working, like a traffic police fellow standing for 10 hours, 12 hours, standing position, or the person who is sitting in front of laptop and working for 10-12 hours. So is your research work also focusing on ergonomics part or human factor engineering in that situation where it is not a dynamic situation, it is not vibration, but still it has the same kind of impact?
Yeah, absolutely. My career has been from the dynamic environments primarily, and that's the way I've gone. But that doesn't mean that we've not looked in other areas. So we're doing work. Another project I've been involved with is looking at, for example, surgeons who are maybe working for long periods of time and they need to concentrate, and so we need to understand how they take decisions and what happens when they get fatigued. And fatigued is I think fatigued is a really bad word in English, actually, because it means so many different things. It could mean mechanical fatigue, like if you have a beam that's work hardening, or it could mean sleepiness, or it could mean boredom, or it could mean exhaustion. So it means all of those things. But that's something that we work in quite a lot, trying to separate those out. And vigilance is part of that. So one of the things that we've done is we've looked at long-term. It has been long-term driving. It's been the context, but actually, it's not about the vibration. It's how do people get tired when they are driving for long periods of time, and what can we do to improve that? So we've had several projects. Many of those have been working with industry, working with automotive companies to make the car feel better. But these are the very high-end cars that are driving on. That are driving on smooth European roads. So the vibration levels are actually very low in those. So although that's something I'm interested in, those principles that we work on, they're universal, really.
Okay, Professor Neil, my next question was related to your projects only, which you have answered, but I still want you to tell us something about your projects in the domain of sports. You have done some work in that direction also.
Okay, yeah, I understand. Yeah, so within sports, we've worked in many areas, actually. So ranging from things like some of the winter sports, like bobsleigh and skeleton bob. So they're quite niche, but they're Olympic sports, so they have some good funding behind them. And through to golf and badminton, actually looking at the biomechanics in those in particular, and how people interact with the golf clubs or with the badminton rackets. Those are things that we've worked on. Badminton has got some quite unique movements that are very understudied. So there's people lunge in badminton more than in any other sport, and that puts stresses on the knee and on the hip. So that was one of the projects that we did. Now a lot of my work is in cycling, where we are looking at elite level cycling. So one of the teams that we work with very closely, they won several World Cups last year, and they broke some of the world records last year. So we're really proud of their achievements, and we like to think we've helped them get there. But some of the things we're doing are things like we're putting pitot tubes on the bikes, so we have a much better understanding of the airflow that's coming over the bike. We're using modeling to understand not only the airflow around them, but the airflow through a whole group of riders, and also modeling how they actually fatigue, so how their muscles get tired. So these are some of the things that have been innovative, actually, with that team. And we work very closely with them. So it's not just been us telling them what to do, but we've worked alongside them, and we're looking at how we can improve what they're doing, and working with equipment manufacturers. So particularly looking at cycling clothing, that's one of the big things for us is the clothing. So where you may need someone to have clothing that's appropriate for a long race where they're cycling in a valley, which might be very hot, and then they ascend 2,000 meters to 2,000 meters where it's cold, but their workload has been very high as they've gone up the climb, and then they descend. So they're now at 100 kilometers an hour going downhill, and the air is quite cold, but they're wet because of the sweat from their climb, and suddenly their workload has dropped. So, and of course, they cannot change their clothing in that time. So that's a real challenge. We haven't got the answers to that yet, but we're working on it.
Okay. Professor Neil, I was going through your press expertise where you mentioned about Industry 4. So can you tell us what is this Industry 4?
Yeah, Industry 4 or Industry 4.0 is often referred to as, really it's about integrating digital technologies into industrial processes. So an example of that could be if you place an order for any item, let's say a laptop, you order a laptop, then the first thing that could happen is a code is generated, and that code then becomes the personality of that laptop. And at any time, you would know what it's doing, what its history is. And so, and it's got that connection, that wireless connection. So that's quite an easy concept. But you now imagine that that's something like a kitchen appliance, or a washing machine, or something which is much more industrial, like an electricity generation plant, a turbine. And what that would have is you can have, well, we used to call it condition monitoring, and Industry 4 is really a development from condition monitoring, in my view. And so what you would have there is a personality for that piece of equipment. So you would know, you could effectively you log into it, and you would know that it's done a certain number of cycles. You would know the part numbers of every part. But it goes beyond that. You would know that the bearing here was replaced at that point with another bearing. You would see its history. But a key element to it is you can also do remote diagnostics. So you don't need to send an engineer onto site. And one of the things that we like to look at is digital twins. So you have so you would have at the most basic level, a CAD model. Then that would be augmented with some cameras, perhaps. So you could look at the machine, you've got a CAD model, but then the live data comes into your CAD model. So you can then kind of try to get a diagnostic of it. And you could go even further with like a multi-physics type of model, where you would then understand the signatures of some of the issues that you might be having. And you don't need to send someone onto site to diagnose. You will still maybe need to send someone to fix the problem. But when they go, they have got the right parts with them already. They would know that, okay, I need to take this bearing and these tools and this piece of software upgrade with me. So your downtime is much, much lower. And it's done on an individual item basis. So I kind of, that's sort of a principle of it, where you're really using an example there. But the idea is that it's connected, things have a personality, they have a digital identity, and it's kind of a ubiquitous. So you don't notice that it's actually there. It will be normal that you don't need to go on site. And with the health situation around the world now, I think that's something that's becoming much more accepted very, very quickly now.
Professor Neil, my next 2-3 questions are related to the students from India who, as you know, they dream about going to top universities world over, and yours is one of them. So if some researcher, some student wants to pursue higher education, higher research domain in your field area, how he can prepare himself? Suppose a student in graduation, he wants to work in the same domain in which you are working. How he can prepare himself for that?
I think there's different ways of getting into that. One of the things that we like to do here is we partner with universities. We have partnerships with some universities in India, actually, in Punjab and LPU in Chandigarh. So we have some good partnerships there. And one of the things that we actually introduced last year was a visitors research semester. So this is something that can gain credit, and so someone can come and work with us as an intern, and then we can give them some qualification from doing that. So that's something that's been really effective for us. We've had a lot of people come through that. We've been 2 or 3 people a year are coming through that system.
You're talking about the internship through which students go.
So, that's right. Yeah. If people are wanting to move into the area for a career, then the best way of doing it is always to get the right qualification for it. There are master's programs that can put you into the direction of human factors engineering. There are several of those around the world. I used to run one for many years when I was at Loughborough. And that's a good way of getting in. That's quite broad. Those ones they also have a psychology element to them on understanding human behavior. In terms of the engineering, though, I think human factors engineering is becoming much more normal. It's not a to one side. To be a good engineer now, you have to understand the human factors. You have to understand how people are going to use the devices that you're designing. You know, really, if you don't do that, you're not going to be a good engineer now.
So this one is interdisciplinary domain, Professor Neil. I mean,
Absolutely.
different branch of engineering, people can think of getting into human factor engineering, right? Whether somebody is from mechanical engineering or electrical engineering. So is it interdisciplinary or specific to particular domain of engineering?
I think it is very much interdisciplinary. The people that I work with, some of those have got a background. In fact, one of my senior staff in engineering has got a background in psychology. So that's perhaps an extreme. And we have people who are, so it's kind of at the merging of psychology, design, and more traditional engineering. So those three need to come together. I think it's a really good path for people that have got a much more of a creative mind. People that really like to think, how could we solve this problem in a way which initially might be a crazy idea. So you know, we encourage our students to have crazy ideas and then to push them and see, okay, 90% of this is just impossible, but 10% of that might be the inspiration you need to come up with an innovative solution. So that's kind of one of the things that we like to do. We're really looking for we like to create creative engineers is one of the things that we say within.
Professor, after somebody does specialization in human factor engineering or ergonomics, what scope do you see for him in the industries in Europe or industries world over? What is the scope?
I would say there is good scope. There is every industry needs it. The growth areas of, in fact, let's say the traditional areas is human factors engineering originally came out of transportation, so particularly came out of the military. When it came out of military aircraft, when they became very complicated and you couldn't fit people in and they couldn't control them, actually was what the problem was. So that's really where it began. That was in the 1950s. Since then, it's grown across all industries. So the big areas, there's the power generation is a big one. There are particular issues in high hazard industries. So that could be maybe nuclear or through mining and drilling. Those types of areas.
IT domain, IT sector?
IT sector, there are many people. In fact, I was speaking to someone only this week who's moving from JCB, the equipment manufacturer, into the IT sector. And the application of that is coming into all kinds of different IT sectors. Fintech, financial technologies, is an area where human factors engineering is really important. If you look at your banking app, that has a real challenge to it. It needs to be very secure and very usable and very fast. It needs all of those. And if it goes wrong, there's big consequences. So that's an area where there's been some beautiful human factors work, actually, drawing those together. So you don't notice it, but it just seems to work well, but it's actually very secure as well. So into the software side, and healthcare is another area which is a big growth at the moment. For the past 10 years, it's really grown where we're designing so healthcare professionals can work at their best. They're under a huge amount of pressure. There's a lot of information exchange, and some of the things that they do are really quite hazardous. So we need to put those together so they can still perform at their best whilst not putting themselves at risk, and that so they don't make mistakes. You know, we were talking earlier about people getting tired, and that was a classic within the healthcare industry. People have to work 24 hours. We need to make sure that the systems are robust to design for real human beings. Real people make mistakes. Real people get tired. Real people drop things. Real people drop their phone. You know, that's normal. To be a human being, you will drop your phone. So if you design it so that the screen breaks every time, then I think that's bad engineering. So it's kind of, I would say human factors, it goes right across many areas. But certainly software is one of the growth areas. And it's something where it's becoming more and more important as more systems go digital.
Professor Neil, one of my last questions is, many students, they go for doctorate or PhD courses after graduation, and some go after masters. What do you suggest? It should be after graduation or it should be after masters?
I think it's very difficult to get a place on a PhD program,
Okay.
and you are also committing yourself to a long time.
Yeah.
So you need to make sure that you are very passionate about your topic,
Okay.
and you also need to make sure that you are going to get a place. So I think that being as well prepared as you can beforehand, and ensuring that you really do know what you're letting yourself in for. I would always say it is better to come with a master's. For us, it would be rare for someone to be accepted onto one of our PhD programs without a master's,
Okay.
because it's so competitive. So we are trying to decide between 100 applicants for one place, and so of course, we would love to offer places to everyone, but someone having a master's is a very key way that we would make that decision. So I would say, I actually think that one of the best pathways you could take is to take kind of one of the classic type of engineering first degrees, then specialize, and at that point you learn what is it that you're really passionate about within that area, and then you're really well prepared. And yeah, I think that's the best way to go.
Okay, Professor, among various requirements for a student to be in PhD, what is the most important thing which a professor will look forward to in a candidate whom he will take for PhD, other than academic requirements? Yeah.
I look for someone that can think for themselves.
Okay.
It's not my PhD; it's their PhD.
Yeah.
I want them to have great ideas. I want them to be one of the things that I look for actually is if someone has made me think something that I would not have thought about without them. So if they come if I ask them a question about, what do you see as being, or who has designed the best piece of equipment in your view over the last 10 years, let's say it's a question, and there are some really obvious answers to that. But if someone, if someone said, "Oh, Tesla or an Apple," or okay, great engineering, fantastic, but it's a bit boring actually. But if someone came and they said, "Actually, what I really love is this new water bottle," I think, "Oh, that's really interesting. Tell me more. What's so great about this?" And it might be all kinds of things about its sustainability and how it's changed their life, and that's actually the type of passion that we're really looking for in a PhD. We want someone who can challenge the norm. The whole point of this is that they're doing something new. No one's ever done it before, and that's what we're really looking for. So it's someone who has got that creative thought process, so they can take a project, make it their own, and they can take it forwards. And so they are the expert. It's their research. It's not that they're doing my research on their supervisor, but I actually want it to be something that they are learning for themselves.
Right, right. I think then, Professor Neil, I have taken your sufficient time, and I am really thankful to you. You answered all my questions and queries. And I also thank you on behalf of all the student community and researchers from India. Thanks a lot, sir.
Always a pleasure to talk. So thank you.
Thanks a lot.